Friends, if you can just look at these and say what the answers are, then that's wonderful. If you are still a little lost as to how to do it, then we can go, we can show that T-table approach, which I do think probably makes it as plain as you can get it to be. So basically your first column would be the number of term you're on, and then your second column would be what's the value of that term. So for example, if you're on your first term, the value in this case would be 3. If you're on your second term, the value would be -15. Your third term, the value is 75. You could always go beyond that, if you need to. So we already figured out they just keep multiplying by -5, so you could always build up in your fourth term as well. Totally up to you. So anyway, so let's kind of go and tell the story. So they had multiplied the 3 by a -5 to get the 15. So we would just say this was the original, that first term multiplied by your common ratio there. And then to get the 75, you can do this in a couple ways, but I think you're probably best off comparing like how did you get from the 3 to the 75? And so you would have taken the 3 and multiplied it by your common ratio twice. So you're on your third term, but you had multiplied by 2 of those common ratios. So then you can always go back and build it in. So put a first power on that second row, and then you could kind of show off that 3 is annoyingly -5 to the 0 power. And that way, if you look at the pattern piece here, you could look at the parts that stay the same. The 3's are always in front. The base is always -5. And then you could compare the part that's changing to the number of term that you're on and find a relationship there. So this little T-table approach is there for you if you ever need it. So to get to any nth term, you would take your original value and multiply it by -5 n minus 1 times. So I'm hoping that whether you needed the T-table or not, that you got 3 times -5 to the n minus 1 for that nth term. But you're basically saying, here's the trick. Here's how you can just jump to any term if you want. So similar story for part B, they just keep multiplying by 2/3 every time, right? Now that we changed the 55 to a 45. So for part B, I hope it makes sense. To get to any nth term, you'd start out with the 1/5 and you'd multiply it by 2/3 and minus 1 times. There you go. So if you're able to just jump to that, then great. And if you're not, then do this T-table type thing until you feel comfortable. Now for part C was not geometric. So if you look at our answers for parts A and B, the answers have a very similar format. And we'll talk about that in just a second in kind of a formulaic type of way. But part C is not geometric, but it doesn't mean that part C doesn't have a recognizable pattern that you could define as the nth term. It just means that the pattern is not going to look quite the same. So as a matter of fact, for part C, while it is not arithmetic, you could think of the numerators as an arithmetic series because they're just adding 1 every time. And you could think of the denominators as an arithmetic series as well because they just keep adding 2 every time. So you could kind of do, in a way, 2 formulas if you want. However, let me just kind of show 2 ways to do this, the short way and the long way. So let's do the short way first. So the short way would be to notice that, first term, second term, third term, fourth term, the top numbers are just the number of term you're on. And then the bottom numbers, they keep adding 2. So, you've got 2 times the number of term you're on. But if n was a 1, you just get a 2 here. So you could, So you could just I don't know why it keeps doing that. Anyway, so you can just add 3. There you go. So that's the quick way, would be to just notice the pattern. Now I am going to show a not so quick way where you actually use the formula from the arithmetic series piece. So on the top, your first term is 1 and your common ratio is 1. So you'd be adding n minus 1 ones. This is a throwback to the arithmetic stuff. And then on the bottom, your first term is 5 and your common ratio is 2, and you'd be adding n minus 1 2s. This is way messier than just noticing the pattern, But for anybody who tends to lean on formulas, this is a way to go about it. And then you could simplify the top by distributing the 1 in and then combining like terms. Lo and behold, you'd get n, which I got on the easier way. And then on the bottom, you could distribute the 2 in. You'd get 2n minus 2 plus 5, which would be 2n plus 3. And you could see you get the same thing that I got kind of by inspection when I did it in the first place. Okay, so if you can do the by inspection approach, great. But if it doesn't jump out at you and you can classify something as geometric or arithmetic, you could fall back on formulas that you've memorized from previous sections to also get the same answer. So there you go. You have some variety now. All right, now let's add a part D to this example. And I'm going to keep things super generic. So let's say your first term is A. Whoops, actually, let's just call it A. And let's say that I want this to be geometric and I want your common ratio to just be R. That way it could kind of represent any common ratio. So how would you get your second term if your sequence is geometric and your common ratio is called R? That's right. You take your first term and you multiply it by R. So that's your second term. How would you get your third term? Yeah, you just multiply by R again. So you get AR squared. How would you get your fourth term? AR cubed. You just keep multiplying by another R, right? Okay. So let's just kind of put some notation in. So if that's your first term, and that's your second term, and that's your third term, and that's your fourth term, then let's say you just keep going down the list and then I get greedy and I say, can you please tell me what the 100th term would be? Could you tell me? And so I'm hoping you could, because to get to the fourth term, you had A times your common ratio and you needed to multiply by 3 of them, right? So that was to get to your fourth term, and 3, and you have a 2 here, and second term, and you had a 1 there. So to get to your 100th term, you need to multiply by 99 of your common ratio. So the point is what is the formula for, just in general, the nth term of any geometric series? So yeah, it would be your first term times your common ratio to the n minus 1. And if you look back at parts A and B, like our answers really fall into that pattern anyway. So the last thing I want to do is kind of make this formula official, something that I think you kind of were using before I told you about it. So this is a formula for the nth term, specifically a geometric series. Oh, not a series, I apologize. Wrong word. Sequence. Okay, so it is the nth term is always just your first term times your common ratio to the n minus 1 power. And you could have done this example just by plugging stuff in where they go by memorizing this formula. But I hope that just by not mentioning it to the very end, you were able to tell me what the formula would be, which is a lot more empowering for you. So chapter 8 has a lot of formulas. It could be very heavy on memorization. And so what I'm trying to do with these lessons is make it so if you can tell me what the formula is, then if you're in the middle of a test and you forget a formula, you could almost stop and teach it to yourself. Or there hopefully will be many times where you don't really need a formula because the number patterns make sense to you without having to memorize a formula or lean on memorization so hard. So anyway, hopefully that makes sense. This is the end of this video, and you should be able to do the A3 Part 1 problem set, hopefully without too much trouble. And if you do run into trouble, I hope you feel like you can ask me questions for the parts that don't make sense. Take care, everybody.